Hello everyone, today in Mathematics Masterclass we'll be teaching you how to solve logarithms of numbers greater than 1. Example 1. Evaluate the following, round off each answer to 3 significant figures. Solution. Number 1. 27.1 square times 327 all over square root of 27,500,000. So let's first of all solve question number 1. Now from number 1 we are going to draw a table. I'm going to draw a table. In that table we have a number. We have number and bring it down. And this is the heading of our table. One part of the table is number, while the other part is log. So we are going to start with 27.1 square. So we have 27.1 square. So we are doing this with the aid of logarithm table. So if you go to logarithm table, you are going to check log 27 under 1, and log 27 under 1 will give us first of all the integer of this number. Remember, when we are doing a logarithm of a large number, if you write this number in a standard form, that 27.1, if you write it in a standard form, it will give you 2.71 times 10 raised to the power of 1. Now this 1 as the power of 10 become the integer of this logarithm. So we are going to write 1 here, point. Then we will now go into the logarithm table. The logarithm of 27 under 1 will give us 4330. And because we are having power of 2, because the whole of this number is raised to power of 2, we are going to multiply this by 2. So 1.4330 times 2 will give us 2.8660. So with this we are done with this one. So we can now move to the next number, which is 327. So we have 327. We are going to write this number again in a standard form. If you write this number in standard form, the power of 10 will be 2. This is one way you can do it. Or you can count the number. You count 1, 2, 3, you subtract 1 from it. So the integer of this number will be 2. Point. Then you now check the logarithm of 32 under 7. Logarithm of 32 under 7 will give us 2.5145. So we'll get 5145 from the table. There is nothing to multiply this with, so we'll replicate it here too. It will be 2.5145. So we can now add the numerator. Now we have multiplication sign here. This multiplication sign in logarithm is addition. So we are going to add the logarithm of 27.1 square to 327. So see, this is the logarithm of 27.1 square is 1.4330 times 2, and it gives us this value. So we are going to add this with this, and if we add them, 5 plus 0 plus 5 will give us 5. Then 6 plus 4 will give us 10. We'll write 0. We carry 1 to this, becomes 7. 7 plus 1 will give us 8. Then 8 plus 5 will give us 13. So we write 3. We'll move 1 to this. So this one now, if you add 1 to this, is 3. 3 plus this will give us 5. So we bring down the point first, then we now write our 5. So now this value now will now be the numerator. So this is the numerator to this. Then we now go back to the denominator, which is 27,500,000. So the square root of 27,500,000. Get the square root. So if you write this number in a standard form, the power of 10 will be 1, 2, 3, 4, 5, 6, 7. So the power of 10 will be 7, because the whole of the digit is 8. 1, 2, 3, 4, 5, 6, 7, 8. So we subtract 1. If we subtract 1, we are going to have 7 as integer. So we are going to look for the logarithm of 27 under 5, difference 0. And that will give us, there is nothing like difference 0 though, in case there is another number. So it's going to be 27, the logarithm of 27 under 5. So that will give us 439,3. So this square root sign is a symbol of 1 over 2. So because of that, we are going to divide it by 2. We'll divide this value by 2. If you divide 7.4393 by 2, we'll get 3.7197. 3.7197. So this value now is our denominator. This value is our denominator. 3.7197 is our denominator. So we are going to take this line here is a symbol of division. So because of that, we are going to subtract the value of the denominator from that of numerator. And the value of the numerator, we have it here as 5.3805. So we are going to subtract 3.7197 from this value. So if we do that, we'll get 1.6608. 1.6608. So this is the value we have. So we are now going to get our final answer. We now go into at logarithm table, not logarithm table this time. We go to at logarithm table. We are going to check the number 66 under 0 difference 8. And that number is 0.5979. Now this one is the integer. We are going to use this one to get the integer. So remember, when we are doing for this, we always subtract 1 from the entire number to get this. Now this time around, we are going to add 1 to this to give us 2. Now we are going to move the point from here 2 times. So if you move it once, it will be here. If you move it again, it will be here. So the original value of this will be 45.79. So the point will no longer be here. So this is the real value of this. So our final answer, therefore, that is 27.1 square times 327 all over the square root of 27,500. 27,500,000 will now be equal to 45.79. But remember, we are asked to write our answers in three significant figures. So this answer written in three significant figures will become 45.8 to three significant figure. Evaluate 95.3 times cube root of 18.4 all over 1.295 times 2.03. So the first thing we are going to do is to draw the table for this calculation. So we are going to create a table, and our table head is, the first part is number, while this one is log. 95.3. So the logarithm of 95.3 is, don't forget about the integer, is 1. By now you know how to find the integers. And the logarithm of 95 under 3 is 9791. 9791. So the next one is the cube root of 18.4. So first of all, the integer of 18.4 is 1. It is 1 because this is where our point is. The point, you move it once. So you move the point once to this place. So we have 1 as integer. Or you count from here, 1, 2. Remove 1. You count from where point is to your left. 1, 2. Then remove 1 from it, you get it. Likewise here, you count 1, 2. Then remove 1. Now you are left with 1. So 1 now is your integer. So we are going to check the logarithm of 18 under 4. And that is 2648. So 2648 is the logarithm. Then because we have cube root here, because we have cube root, we are going to divide by 3. So if you divide this by 3, we are going to get 6. 0.4216. So let's say we move this one here again. 1.9791. So this will become the numerator. And because we have multiplication sign here, if you have division, you subtract. If you have multiplication, you add. So we are going to add this to this, and if we do that, we'll get 1 plus 6 is 7, 9 plus 1 is 10, write 0, carry 1, 8, you add that 1 to 7, become 8 plus 2 will still give us 10. Then we add 1 to 9, give us 10. 10 plus 4 is 14. So we move the remaining 1 to here, but first of all we bring down our point. So we are now going to 1 plus 1 is 2. So we have 2 here. So this is our numerator. Now we are now going straight to the denominator, and the denominator. So 1.29 raised to the power 5. The integer is 0. It is 0 because you did not move your point. And if you are to write 1.296 in a standard form, it will be the power of 10 in this time around is 0. Or you count. If you count to your left, you have only one digit there, which is 1. And 1 minus 1 is 0. So we are going to check the logarithm of 12 under 9. Logarithm of 12 under 9 is 0.1106. 1106. We are going to multiply it by 5 because it's raising to power 5. And if we do that, we are going to get 0.1106. 0.5530. 5530. So the next one is 2.03. 2.03. The integer this time around is still 0 because we have only one digit before the decimal point. From that one digit to give you 0. So point. Then we check the logarithm of 20 under 3. The logarithm of 20 under 3 will give us 0.3075. 3075. So we are not multiplying it with anything because there is nothing attached to it. So 0.3075. Multiplication sign here. So we are going to add 0 plus 5 is 5. Plus 0 plus 5 is 5. 3 plus 7 is 10. Add 1 to this. 6 plus 0 is 6. 6, yeah. Then we have 5 plus 3 will give us 8. Bring down the point, then we have our 0. So this will serve as our denominator. Serve as our denominator. So now we are going to subtract the denominator from the numerator because of this division sign here. So if we do that, we have 7 minus 5 to give us 2. We have 0 minus 0 to give us 0. We have 0 again minus 6. So we have to borrow 1 from here. That one we borrow is 10. 10 minus 6 will give us 4. So we are now left with 3. And 3 minus 8 can't go, so we borrow 1 from here again. Attached to it is 13. 13 minus 8 will give us 5. So then we have 1 minus 0, and that will still give us 1. We bring down our point. So then we are going to check the at logarithm table this time to get the real value here. So in at logarithm table, we check the logarithm of 54 under 0 difference 2. And that will give us 0.34, 0.34, .3469. So we will move our point. You add 1 to 1 to give us 2. You now move your point 2 times. 1, 2 to this point. So the final answer, therefore, we are going to remove this point from here so that the real. So the final answer of 95 1.8 all over 1.29 raised to the power of 5 times 2.03 will now be equal to 34.69. Approximately to 3 significant figure will be 34.7. So 3 significant